What's going on, Algebra Bros? Mr. C again. And in this example, we're going to solve the following rational equation, which, as you're going to see, morphs into a quadratic equation. Just a couple of quick reminders about how this thing was set up. We are working with a work application problem, and it's concerning Jim and his son Billy and the time it takes for them to clean the house. We're both working together and also working alone. We learned that the true unknown here is Jim, Billy's dad's total time it takes him to complete the job. Um, so we designated that by x, which means that the part of the job completed in 1 hour would be 1 over x. Now, Billy's time is based on Jim's. It said in the problem that it takes him 1 hour longer to clean the house than it takes his dad alone. So therefore, it would have to be expressed as x plus 1. So that means the part of the job completed in 1 hour is 1 over x plus 1. It also said in the problem that together they can clean the house in 4 hours. So after just 1 hour of time, 1/4 of the job is done. So the equation 1 over x plus 1 over x plus 1 equals 1/4 really is based upon the fact that, in this 1 hour of time, Jim's going to make a contribution and so is Billy. Jen's contribution is represented by 1 over x, and Billy's contribution is represented by 1 over x plus 1. And so, like I said, it gives us a rational equation, and we're going to go ahead and solve it right now. First, note that an LCM is provided for us. It's 4x times quantity x plus 1. And what we should do with that LCM is put it in front of each of these three fractions. So 4x, quantity x plus 1, going in front of the fraction 1 over x, plus 4x, quantity x plus 1, going in front of 1 over x plus 1. And even on the right-hand side, let's put 4x, quantity x plus 1, in front of 1 over 4. And the whole point of distributing the LCM here so that we can cancel out all of these denominators. Let's go in order from left to right. With the first fraction on the left, the denominator of x will cancel out with the factor of x in the LCM. What's left over is 4, the quantity x plus 1, and then 1. With the second fraction on the left, quantity x plus 1 in that denominator is going to cancel out the quantity x plus 1 that's part of the LCM. What's left over is 4x and the 1. And on the right-hand side, the 4's cancel out. And what's left over is x times quantity x plus 1 times 1. So this is going to take on a cleaner form now. Once the dust settles with our first simplification on the left, we're going to have 4 quantity x plus 1. With regard to the second fraction, we're going to have simply 4x. And then on the right-hand side, we're going to have x, quantity x plus 1. Okay, next thing we want to do is clear parentheses via distribution. So we'll go ahead and do that. We get 4x plus 4 plus another copy of 4x. On the right-hand side, x squared plus x. And lo and behold, we have a quadratic equation staring at us. What we should do now is combine any like terms and set the quadratic equal to 0. So on the left, we'll have 8x plus 4. On the right, nothing to combine. But now what we're going to do is subtract 8x and 4 from each side. That gives us 0 on the left. On the right-hand side, we're looking at x squared minus 7x minus 4. So your first attempt at solving for x should be factoring, but notice that there are no factors of -4 that would give us -7. So you have a couple of other options. You could complete the square, or you could use the quadratic formula. Since most people are hip to the quadratic formula, in other words, they prefer it over completing the square, I think I'm going to go that route. So let me go ahead and show you how to do that. It's going to be x equals negative b, in other words, negative 7, plus or minus the square root of b squared, again, negative 7, this time squared, minus 4 times the value of a, which is 1, times the value of c, which is negative 4. All of that goes on top of 2 times the value of a, which is 1. When you clean things up in the formula, we're going to get two answers for x, 7 plus or minus the square root of 65 all over 2. And what I'm going to do is separate those two values out. One value of x uses the plus part of plus or minus, that's 7 plus the square root of 65 all over 2. Or what we'll have is 7 minus the square root of 65 all over 2. So that would be the second answer for x. So since we are in an application setting here, I recommend typing each of these values of x into the calculator and perhaps rounding to one decimal place. When you do that with the first value of x, we get x is roughly 7.5, meaning that it would take Jim about 7.5 hours to clean the house all on his own. If you take a look at the second value of x, we get negative 0.5 to the nearest tenth. And of course, in this application setting, that doesn't really apply or make sense. All values of time should be positive, in other words. So it looks as though 7.5 is the official value of x and represents the official amount of time it takes Jim to clean the house working all by himself. So with that said, with regard to Jim, it takes him 7.5 hours to clean the house all on his own. As for Billy, what we have to do with 7.5 is add 1 to it, because it states in the problem that it takes him an hour longer to clean the house than it takes his dad alone. So what that means for Billy is it takes him about 8.5 hours to clean the house all on his own. And that's where our solution to this problem officially ends. As always, let me know if you have any questions whatsoever. Otherwise, thanks for watching. I'll see you in the next video. Have a good one.